All right, we're in 2A today, graphing linear and absolute value inequalities. And so it's not just going to be the lines today for a linear function or just the absolute value graph, but we're going to be shading different sides of those graphs. All right, so there's a good example right here on page 117. This line is y equals negative 3x minus 2. And then this shading in the line represents y is greater than negative 3x minus 2. That's a y-intercept of negative 2, slope of negative 3, stuff that y'all know how to do. Okay, we have a greater than sign, so we get a dotted line, and then we're shading to the right or where the x's are greater than that, because when y is greater than this function, we're talking about the values to the right of that line. All right, let's just jump into example 1. So they give it to us in what we would see is recognized as standard form, all right, with the x and y on one side of the inequality here. The way that we learned how to graph these the first time we did it was solve for the intercepts. Plug in 0 for x and find your y-intercept. Plug in 0 for y and find your x-intercept. I'm just going to get y by itself and use slope-intercept form. So remember when we do that, it's PEMDAS backwards, so I got to get rid of, I'm solving for y, so I need to get rid of the x here that was added on, so I'm going to minus x from both sides. I'm going to go ahead and write that in slope-intercept form on the right side. So that 2 and the minus x are not like terms, so it splits up like that. Now I got to get rid of 4 times y, so I'm going to divide by 4. I'm going to divide everything by 4. Here's how it cleans up. This is y is greater than. So this negative x over 4, our slope is negative 1/4. Then I can write the x beside it. Obviously, positive 2 over 4 reduces to positive 2. All right, so we need to go graph y is greater than negative 1/4 x plus 2. So let's go to our graph. But you know how to do this. We can draw a quick sketch. If you're doing an assignment in Connect Ed, the graphs will be there for you to pick. All right, y-intercept at 2. All right, the slope says go down 1, right 4. All right, or I could go up 1 and left 4. All right, so it's that. Now we need to see what type of line that we need to draw. It's just greater than. So my line here is going to be a dotted line. If it was equal to, it would be a solid line. Okay, my line's going like that. And now we need to shade because that's part of the inequality. Where do the solutions for this graph fit? Greater than the line that I just drew, which is going to be this side. So we're going to shade that. What's important to know, any solutions to this inequality come inside the shaded part, all right? If they pick an ordered pair that's on the line, like even the y-intercept, if you plug it in, it would not be true. If you plugged in the x and y, it would not be true because it was not an equal to inequality there, all right? So as you can see what's going on down here, guided practice 1A, you would need to multiply this whole thing by 2 to fraction bust. That's a good review for some stuff we've been working on. You'd get y by yourself and graph. Both of these graphs in guided practice would need dotted lines because there's no equal sign there. So just kind of keep that in mind. All right, let's keep going. I'm going to jump all the way to the absolute value stuff, and we're going to go to the bottom of page 118, and we're going to look at the absolute value graph. I'm not even going to do this one. I'm going to walk you through it. First of all, it's greater than or equal to, so we're going to draw a solid line. You learned how to graph absolute value and then move that down 4. So this is a normal width absolute value graph, shifted down 4. They drew the graph and shaded greater than those lines, which happen to be inside here. That's above those lines, or greater than. I'm going to jump down where we got to do a little bit of work. Okay, let's come down here to guided practice 3A. And I've got this. It says y is less than or equal to 2 times absolute value of x plus 3. Now that's ready for us to graph, all right? Let's use our transformations that we've learned to do that. I've got to get y by itself still if that's not done, which it's done here. All right, so 2 times the absolute value of x graph is going to be a little skinnier than a normal absolute value graph. Remember, we call that a vertical stretch. So it's going to be stretched a little bit, and it's going up 3. Now, if you need specific ordered pair, then get on your calculator and do that, all right? So we're going up 3 is where my vertex is going to be, and it's a little skinnier than this graph, all right? It's an equal sign, so it's going to be solid lines. So I'm going to graph it like that. And now we're going to shade less than that. Well, above the line is greater than, so less than is all of this. All of this graph out here, we're shading all this, just showing and representing what part is included in our inequality. So any ordered pair from the shaded region, and again, remember, this goes on forever in all directions. If it's in the unshaded part, it's not a solution to our inequality. If it's in the shaded part, it is a solution. The last place you can have solutions for this graph is on the solid line because it's equal to. So if you pick any ordered pair on the solid line and plug it in and plug in x and y, you will get 3. And 3 is less than or equal to 3. That's why in this one, a solid line answer works, a dotted line answer doesn't work, like in example 1. Okay, let's make sure we're good. Let's go down here to 3b. Make sure we can graph a horizontal shift as well. I've got this, y is greater than or equal to 3 times absolute value of x plus 1. This is even skinnier than the previous one. See the 2 out here in front of the absolute value. This one's got a 3 out front. It's even skinnier, but we can go draw this graph. Remember, with the x, if it's absolute value or quadratic, inside absolute value bars or inside parentheses, this is a horizontal shift, and this shift tells us we're going left 1. Remember, it's backwards. So again, remember up here, that plus 3 was up 3. So just kind of understand when it's absolute value, we can apply our transformations and graph. So I'm moving the whole graph left 1, all right, and it's going to be even skinnier than this graph. You got to be able to pick that out from your connect-ed choices. Use a table in the calculator if you're having some trouble with that. Go find what ordered pair fit. It's going to be a solid line because I have an equal sign. It's facing, we didn't flip or anything, so it's going in normal direction. So it's going to be even skinnier than my last graph. So there's the absolute, or 3 times absolute value of x plus 1. Now the inequality says, hey, graph greater than that. Greater than is above the line, so that's all the stuff inside here. So my shade comes inside the line. People are like, well, coach, how am I going to end up shading this? I got a pencil or whatever. Just make it dark or darker where you're shading. We're going to deal with some things, graphing these inequalities, that we can have some tips in a program called Desmos, and we'll get there, all right? All the solutions for this inequality come from the shaded part or on the graph, on the absolute value graph, because if you plug those in, it will make this a true statement. If you pick any ordered pair outside of the shaded region or outside of the solid line, it would make this inequality false, all right? So there is 2-8. That's wrapping up what we're doing in Chapter 2. We'll be getting ready to test on this stuff pretty soon. Remember, if you have any questions on any of this at any time, questions on transformations, how the shades work, how do we get solid or dotted line, come see me and let's get that fixed. Thanks.